Thank you.
That's going to be about the garbage collection that takes place in other components of our typical application. Because let's say that you're a backend Java developer and you build an application. Usually that application stores data in a database. Doesn't matter which one, relational or NoSQL. And the database puts your records on disk. Quite frequently, those are solid state drives. And those components also use garbage collection. Not everyone knows. I managed to discover that because I worked for the database companies for the last 8 years, but I recognize myself as an application developer, Java developer. But that was a big surprise for me. And that gave a birth to this topic. And I'd like to share with you some of the insights that might be interesting for you. So why would you care if this is about the garbage collection, but not on the JVM side? Why would you care? First, you will see that because we as Java developers, we heard many times that Java is probably one of the few programming languages that uses garbage collection in runtime. But Java is a programming language in runtime that implemented GC successfully, right? It's a successful implementation of the garbage collection, but it's not the only one successful implementation. And you'll see that even PostgreSQL, a very well recognizable database on MySQL and Oracle, they also use garbage collection, but only a few know. And also, it will help you to understand if, let's say, it's quite frequently we go in production that we have some performance issues or bottlenecks. You need to investigate. If everything looks good from the application standpoint, then the problem might be on the below the stack. It can be in the database, it can be on hardware, and sometimes GC or databases and hardware can influence the bottlenecks you see. And that will help you just to navigate through the different performance resolution workflows and have a proper conversation with your DBAs or DevOps who are responsible for the databases and the rest of the infrastructure.
Dennis, could you minimize the window up in upper right-hand corner?
This one?
Yeah. Okay. Thank you.
And today, please welcome my virtual friend and Java Joe. He's a senior engineer and architect who was charged to build a new service for a pizza chain. Not a pizza chain yet, that's a new business, a startup company that plans to open, let's say, the first location in the New York City. But then, if everything goes all right, they are planning to expand across the nation and probably across the world. And Java Joe, as a software engineer, selected the following simple architecture. His Java application is going to be using Spring Boot. Who uses Spring Boot? Spring Data? Any micronode people? Workers? Yeah. No. Just. Anyway, doesn't matter. Java Joe's preference is Spring Boot, Spring Data, and other components of the ecosystem. Why not? Yeah. And initially, the first version, when the startup will be launched one location in the city, they will be using PostgreSQL. Why not? Wonderful database data will be kept on SSDs. If the startup idea takes off and they would need to expand that, then when the company will be going, Java Joe considers YugabyteDB, which is built on PostgreSQL source code, and that's basically distributed PostgreSQL. However, Java Joe went ahead, he implemented the first version of his application, and he decided to do a simple load test. So what that load test did, he loaded 1 million records, 1 million pizza orders in the database. He executed a few million inserts, updates, deletes, etc. And in the end of the test, all the data was removed from the database through the application layer. But when he checked the database size, he was surprised. The database size significantly exceeded the size of the initial data set, but the data set was removed. And he got puzzled. And as a senior software engineer, he wanted to find answers to his questions. So let's see what were the results of his investigation, what he discovered, and how that helped him just to understand. And that helped him to understand that the GC belongs not only to the vault of the Java applications, but when you run the Java application in runtime, the Java application can also generate garbage in other places by talking to your database. Yeah.
When you say that the database size was bigger than at the start, how is that measured? Is that on the disk? Is it the memory it uses?
Yeah, disk.
Just disk.
Yeah, just disk. And also you can check the memory. And I will be showing you today the memory part for the PostgreSQL, so you'll see what's happening. So when Joe started, the first hint for him was multi-version concurrency control. So we all know that it's possible to connect to open dozens or hundreds of connections to our database, such as PostgreSQL or MySQL or Oracle, and execute, let's say, hundreds of requests in parallel. And usually, if you're using a relational database, then your queries will be returning consistent result set. Even, let's say, if multiple queries updating your data in parallel. So, and this is possible thanks to the multi-version concurrency control. So for instance, if to take this example, let's say that you have transaction number 1, and this transaction number 1 just wants to check the status of the order with ID number 1, and presently the status of this order is ordered. Someone just pulled up his phone, put an order for some tasty pizza, and the pizza is still waiting in the queue. And some application thread is trying to get the status right now. But at the same time, before this select is executed, there is another transaction that is executed from another thread of your Java application. And that transaction wants to change the status for this order from order to baking. And this update happened before the select. But this second transaction is not committed yet. The question is what this request should see. Should it see the status ordered or the status baking? You want to see the status that is already committed to your database, which means that this transaction, unless you change their concurrency control, this transaction will see the status. Because this second transaction might never commit. It might roll back, it might fail in the middle of this execution, etc. And you don't want to see any dirty writes on your application side. That's why you will see the ordered status for this request. And also how is it related to the garbage collection? Because imagine this, at a given point in time, the database needs to store 2 copies of a record. One copy will be returning the currently committed value to your application, and the other copy would be holding the data that another transaction is updating right now. And this is actually how garbage gets generated in your database. So let's switch to the terminal. So what Java Joe did, he created a simple. I think nobody sees this. He created a simple table, pizza order with 3 columns, pizza order ID, status, and the order time. That's enough for us to understand, let's say, the internals of garbage collection in PostgreSQL. So let's do this. I'm connected to Postgres. It runs on my local laptop. We don't have any tables yet. And there is a simple Spring Boot application with a few REST API endpoints. And those REST endpoints allow me to create a new order in the system, then update the status or order time, and then delete the order, just 3 API endpoints. So let me start this app. The app connects to this Postgres instance. Once it's connected, you will see that this table is created. It's an order. If you check for any records, you'll see that there is nothing in here, no any data. And this is what we are going to fix. So the first request is we are triggering our API endpoint. We are asking to create a new pizza order with the following ID. Done. So you can see that their application Hibernate generated this insert statement. And if you check the table right now, you see that the data is in Postgres, like simple, like all those things that we know. But also in PostgreSQL, there are plenty of extensions, and one of those extensions led us to look into the state of the PostgreSQL memory. So you can see how many versions of a single record the database has. So for that, I have a special function that uses that extension. So the function name is from Heap page. Let me write it down, and then I will explain you all the arguments. Select from Heap page. The function accepts 3 parameters. The first one is your table name. And next 0, 0, that's a range for your pages in Postgres. You have this data. Select from. In Postgres, all the data is split into pages, and inside of those pages, you keep your records. So that's our first record that we've seen in the table. That's the offset of this record in the page. The state means that the record is normal. Whenever you select this record, this version of the record will be returned. And also you need to take a look at these 2 other columns. This is xmin, means that that's the ID of the PostgreSQL transaction that created this version of the record. And xmin, xmax is the ID of the transaction that deleted this version of the record. But when xmax is set to 0, it means that the record is not deleted, it's live, and that's the latest basically version of the following record. And that's the record that you see when you execute a request like that. That's our record. So now, imagine that the pizza, it's time to bake the pizza. The chef is ready. And what it does, the system changes the status for this order to baking. Changed, right? You can see Hibernate generated this update. If you check the table, the status is changed. But now, if we take a look into the memory of the database, you see that there are 2 records, 2 versions of the same record. And they exist, even though your application sees only one of them. So let's figure which one of them is the latest. So that was the first version of the record when the status was set to order. That's the offset. But right now you can see that the xmax value for this record is on 0. And that's the ID of the transaction that deleted this record. And the same transaction created a new version of this record. So effectively, as a summary and update, the relational database is a delete plus insert. It's like one version of the record is deleted and the new one is created. Okay. So let's see what happens when the pizza is ready and hot and waiting to be delivered. So let's change the status to delivery. Someone picked it up, updated, right? And 3 versions of the records. 2 are garbage, and the last one is what our application sees whenever it requested for the next time. And it should not be surprise for you if, let's say, change the status to Miami, meaning the pizza was delivered. You'll see that I have 4 versions of the records. And that's the last one. That's the last one. So what happened then? And that's just the simplistic use case. And you can imagine that usually your applications, there are dozens and hundreds of applications updates in parallel, you insert data, you update data, and basically under the hoods, the database will be generating new versions of your records whenever you need to update anything. But same as in Java, PostgreSQL or MySQL or Oracle, they have a garbage collection process. And the garbage collection, same as in Java, it takes place in background. And there are 2 types of garbage collectors in PostgreSQL. The first one is standard one. It can run in parallel with your application and collect all those dead records, mark the space as available, and it can run concurrently with your application request. So like that's an auto garbage collector. It's called auto vacuum. And it doesn't block your selects, updates, deletes, and inserts. So generally, let's say that you have a page in PostgreSQL that kept several live records. And some of those records were dead, meaning that old versions of those records. When the garbage collector runs, in this page, this dead space will be marked as available for the future data that the database will accept. Sounds familiar, right? This is basically what happens in Java. No any big differences. Difference is that that's a database that is written in C++. Full vacuum is comparable to the stop the vault pause in Java. Usually many DBAs and those who are responsible for running your databases, they prefer to avoid this because that's a stop the vault. It means that your application request will be put on hold and tables and indexes will be rebuilt from scratch. But sometimes it happens. It's probably that was a typical and usual operation back in the days when nobody was requiring us to be up and running 24/7. But these days, DBAs and the DevOps, they're trying to find some other means how to avoid the full vacuum. So let's run this test. The auto vacuum that happens in background has several thresholds. One of the thresholds is like based on some time, some frequency on the data volume. But right now, the data volume of my database is tiny. I just have, let's say, 4 records, which means that we can trigger this vacuum. To trigger this GC, you need to type in vacuum command, and it checks this table. Even this time it took a little bit of a while. But now, if you check the state of the Postgres memory, you can see that this space is free. It was labeled as free one, and it can be reused by some of by future requests. Why this one says redirect to number 4? I have a primary index in the pizza order table. That's the primary index, and the primary index was referring to the first version of the record when the status was inserted in the database. And the standard vacuum did not update the index. But for Postgres, it's not a big deal. So like when you do search and if the search uses the index, the primary index, then generally what the database will do, the index will get to this offset, to this version of the record that no longer exists. But then it said that jump to offset number 4, and that's my record. That's my version of the record. So now let's say that you want to update the order time for some reason for this order. You updated it, and if you take a look here, this space was reduced. Right? So like same as in Java, you have gaps in your pages, you have gaps in your memory, and you would have gaps on disk when this data is flashed to disk by Postgres. But there are free gaps, and those gaps will be used by the database. It's smart. It tracks the available space. Finally, if you decide to delete someone did a mistake and you decided to delete the order, or you delete it, it's deleted by the application. You can check that it no longer exists in the table. The table returns nothing. But surprise, even if you request to delete it, the data is still here. You have 2 versions for the record that are not garbage collected yet. But they will be garbage collected eventually, right? And just for the sake of the experiment, again, you can garbage collect everything using the standard vacuum, or I can run the full vacuum, which basically reveals everything. That's a sort of a stop the vault GC in Postgres. You just need to add this parameter vacuum full. It will take a little bit more time, even on this tiny database, but once it finishes, if you take a look at the Postgres memory, it says that this page is out of range, meaning that there is only live data in this table, and all the data was garbage collected, and there is nothing, any traces are left in your PostgreSQL instance. Okay, so this is the database. The GC exists. The name of the garbage collection process in Postgres is vacuum. Other relational databases can use a different term for that, but it exists because you have multi-version concurrency control. That's done for good. It's not bad. It's done for good, so that your applications can execute hundreds or like thousands of queries in parallel, and those queries request see consistent snapshot of your data. That's why AGC is needed. So, oops, I always confuse these two buttons. It's like this wants my attention. So this we can switch. Yeah, we don't have time today to review the distributed SQL databases or distributed databases, but Postgres is an example of a relational database, single node database, but even distributed databases, they also use garbage collection. Anybody who uses Cassandra? Cassandra, like Cassandra and YugabyteDB, like for instance, YugabyteDB is a distributed SQL relational database. And it also generates versions of your columns whenever you update the column in your record, a new version will be stored. And then the old versions of your columns are garbage collected later. The only difference in that's a different storage system, and there are different approaches for that. And the garbage collector in YugabyteDB or in Cassandra is called the compactor. Like the compaction process is effectively just to take all the data that you have in your database, just and remove whatever is no longer needed. So it's also the GC. Okay, enough of the database. So now suppose that Java Joe figured out that MVCC exists. He is confident right now, he understands. While let's say he saw the results of the first test show the data size was not null, but it was big enough even when all of the records were deleted. And then he decided to run a load, extended load test for multiple days. And during the first days, the throughput was fine, but then suddenly it dropped, and never returned back. So he returned to his checklist, performance troubleshooting, and checklist. The application was all right. No any complaints about the app, about the JVM. The databases were running all right. It doesn't matter whether it was Postgres or YugabyteDB for his pizza company, but there is only one hint. SSD was 80% full, and he started looking into their SSDs. So before we talk about SSDs garbage collection process, a little bit of intro. When you have the storage device, all their space, disk space is split into blocks. You have just block, and inside of this block you have your pages. A page size is usually 4 kilobytes. But it can be different, it depends on what the manufacturer set at the factory. And then inside of those blocks, you have a lot of pages, and inside of those pages, you have data. And this is actually where also the term block I/O comes from when you work with your SSDs. You use different block I/O calls, and those block I/O calls with pages. So the page is the most granular level what you can read from your disk device. And also the pages can be used like here with some data that was flushed from your database or from your application if you use file APIs of Java directly. And the pages can be also free. So also when let's say you have this application, Java Joe has it. You put a new order in PostgreSQL, and eventually PostgreSQL flushes data to disk. Let it be the write ahead log file or database files. The database will write pages to SSD, and the data is always written to a free space on SSD. So you have this new data coming, let's say, from PostgreSQL, and this new page with new data will be written to one of these free pages on the SSD. What happens when you want to update? Let's say on the Postgres side, you're changing something, right? You changed, let's say, the version, you changed the column of your pizza order that generated the second version of your record, and that updated just one page in Postgres. You just updated one page in Postgres, and Postgres wants just to flush this updated page to disk. But update on the SSD level happens differently. So SSD knows that, all right, that was the previous version of this page. And I will label this previous version of the page as stale. It's like that data no longer, it will no longer be needed. And then the new version of this page will be written to an available space like this one. So effectively, when you update, when you send an updated page to the SSD, the previous version of this page will be marked as stale, and the new page will be written to another free space. And generally, when you do this insert updates, especially with write and workloads in SSDs, you can have blocks that have, let's say, use data, stale data, and just a little bit of free space, which means that garbage also gets generated on the SSD level. So the question is, before we talk about the garbage collection on SSDs, why that hardware manufacturers and engineers decided to introduce GC? Why they could not, basically just erase a page, right? The thing, it's all about physics. When you read a page or write a page to the SSD, you apply one amount of voltage. But when you need to erase, that's a little bit higher voltage, and that can damage nearby pages. So for instance, if it were possible to erase at the page, like right now, if you try to erase at the page level, then these nearby pages can be corrupted. So that's why the GC exists. The GC basically takes and erases a full block with all of their pages in it. So SSD garbage collection process is extremely simple. So first, what SSD controller does? Let's say I need to clean this block because there is a lot of stale data. And SSD finds a block with 3 pages, completely pages, and it will move all the live data to this block. So like all these pages, live pages will be moved to block number 2. So that's going to be the state of block number 2. And after that, once all this live data is moved to the block number 2, the block number 1 is erased just completely. So this is how it works. And this garbage collection process, and garbage collector on SSDs in SSDs is called garbage collector, the same name, not macro, not compaction, it's called garbage collection. And it depends on the special space. Right? You know that like when you give some memory space to Java, you want to allocate some extra space so that the GC has enough room to run the GC in the background without any load poses. And when you buy, let's say, 100 GB disk drive, then in fact, the size of this disk drive is usually 10–20% bigger. Like here, you would have usually the size, if you have 100 GB, then the overall size will be 128, because those 28 gigabytes would be for the factory set, for so-called factory set of the provisioning space. And that over-provisioning space is used solely for the SSD needs. And one of those tasks is garbage collection. But also, the GC logic in SSDs is wise enough. For instance, in the beginning, when you, let's say, use only probably 20% of your user space on SSDs, garbage collector will be using your user space for the SSD needs as well. It will be using it. But as long as, let's say, the user data volume keeps growing, the less and the less space will be available for the GC on SSDs. And that's the time when you can see, let's say, the throughput drop on your performance chart. And that was the true chart, yeah.
Is it possible to get a report of out of space when you still have space but the garbage collector hasn't finished running?
With SSDs?
Yeah.
I don't know. Probably there are tools, there's certainly tools, but I was not looking that deep on SSDs. Usually what I've seen personally in my life, that graph, it's like every company went in production, they were running a Java application on a distributed database for a week, and then suddenly the throughput dropped. And they started figuring, so the problem was on SSDs, because SSD was utilized on 50% was used, which means that the less space was available for the GC, and that was expected from the SSD standpoint that the throughput will go down. So here is just as a recommendation, like if you see, like, do those extended tests for your SSDs, and if you see that the throughput drops dramatically and there is no any problem on the application or database size or other layers, then either provision SSDs with larger capacity, or if you use SSDs for your databases, you can run distributed databases. If let's say you use relational database, it can be YugabyteDB. If you use NoSQL database, it can be Mongo, Cassandra, it's up to you. Those databases have cluster of nodes and each node has an SSD attached. All right, Java successfully deployed and the startup became Heap. They operated many locations and he learned that garbage collection is in fact a widespread technology that is used not only by the Java, but it's also used by other well-known products in the industry. And also probably one of the last thoughts for you, whenever you decide to switch jobs and anybody dares to ask you about how GC works in Java, you can say, do you want me to talk just about Java or how the GC also works in other components that are typical in a Java application. So okay, and those are resources. Thanks.
Any questions for Dennis? No question?
Yeah, from the books usually a quick thing. Those are wonderful. I'm a guy who works in distributed systems. And I highly recommend at least two books. The first one is Designing Data-Intensive Applications. If you want to understand how distributed systems operate, but you're just trying to find the fastest and the quickest door to get introduced to this topic, check that book. If you are interested in database internals, in a way, then check the database internals book. It's written by a database engineer for the application developers. And if you decide to read both books, then read the Designing Data-Intensive Apps first, and then switch to the data internals. All right, thanks a lot.
Thanks, Dennis.
And we need to switch. Right?
I hope I have better luck with the connection. Thanks. Come on, get out of the way. Okay. So we're going to talk about ChatGBT. Slightly popular topic these days. So are these from Zoom? All these things?
No,
I can't grab it here.
You should introduce the speaker.
This is Frank. He's in charge. Frank, if you wish to be on video, you need to turn on your video on the Zoom because it's not working from here.
Okay. I have. You know what? I've got the video over there. Don't worry about it. I'll merge in later.
Okay, have fun.
So everybody knows me. Okay. So I gave a talk on ML like last year. Was it last year at the Credit Suisse? Talked about the JSR 381, which was visual recognition for Java. So I worked on that with my colleague Zoran in Serbia for like years because we didn't want Python programmers to have all the fun. So we built a Java API. So I'm going to kind of go back a little bit just to explain, because some people weren't there, what all this is, what ML is. But real quickly, then I want to dive back into the programmatic aspect. Come on, man. Okay. So yeah, those are our topics. So what do you think is going to be the most popular programming language for this year?
Fourth.
Prolog.
Why?
Python. Anyone else?
JavaScript.
JavaScript.
English.
English. Okay. Go. Okay. Well, I covered it up. So because that's at the end, I'll release that. So it's not Java. So we'll see what it is. Come on, bro. Let's go. Okay. So machine learning. So here's the work I did with Zoran. So if you want to do visual recognition in Java, Oracle is now using this in the course at the JCP meeting in Singapore next week. So they're going to use our API. It's a very simple API. And the reason why we did that, because there's like 15 Java APIs out there to do visual recognition and machine learning, but they're all C language, which is some simple syntax sugar. It's not really Java. Like you have to understand C to program with these things. We were like tired of that. So we want to build a real Java library for Java developers. So you feel like, yes, this is Java. This is not C language. I don't have to put like parameters, like 10 million parameters in a method, like you do in C language. I mean, C was my first love, so it's not anything against C language. Okay, so there was this guy back in the 40s. So he said this, that the most interesting aspects of the world is that it's made up of patterns. And nobody paid attention to him. And then the ML, the ML conference at Dartmouth came out in the mid 50s to talk about all kinds of other stuff. And of course, we didn't have computing horsepower then, so it didn't really go that far. But he said this before that conference, before the big Dartmouth conference, but nobody paid attention to him. So we know as programmers, this is a very familiar book, right? There's design patterns. There's that word, right? And this book was influenced by that talk using pattern languages for OOP, using pattern languages. We know about regular expressions. Those are patterns. And it turns out that regular expressions, who knows why they were invented? Anybody know why they were invented? We use them every day, right? Why were they invented?
Because we needed them.
Well, of course, we needed them. They were invented for machine learning. So back in the 40s, when artificial neural networks were invented, actually, it goes back into the 30s, when someone thought of it, but they couldn't implement it. So someone came up and implemented it very crudely in the 40s. So to test it, a scientist, Stephen Klein, he invented regular expressions to test artificial neural networks. They were invented to test them on the use case was text. That's why they were invented. Yes.
That why it also
Was it?
That why it also
Well, if you feed it into ChatGBT, it becomes intuitive. And I'll show you an example. So that's why regular expressions, but these are text patterns. Remember that word, it's a pattern. When we look out at the world, and in my opinion, it's universe, it's not just world, we see all kinds of patterns, right? We see, like, since I'm a musician, there's patterns all over the place in music, right? Whether you're a jazz musician, rock musician, pop. If you're an animal looking for food, there are patterns. And my dog, when knows how to get food for me, knows what to do, right? There are patterns. If you play sports, if you play, American football, or regular football, real football, or the football where you don't use your foot, it's still called football. When I worked for many investment banks, we used patterns, right? So patterns are all over, especially, when I was in high school, I wanted to be an astrophysicist. Until I found out that I had to work at night all the time in the observatory. So I sort of gave that up. But there are things, there's something that really dawned on me. There was something called Chandrasekhar's limit. Bless you. Something called Chandrasekhar's limit. And it's when a star it kind of grows and becomes chaotic and unstable. And then what happens? Supernova, right? It becomes so chaotic, it's supernova, and then it comes back to a more stable state. So I always remembered that. And then I thought, like, when I was being a musician, I thought about like Elvis Presley. Why was he popular? Why were the Beatles popular? And then with C program, when I was a programmer, why were things like, like Make was becoming a pain in the tuchus to deal with, right? It was complexity. And then it blew up. So like, oh, then it came back to a more stable state with other tools. So I thought, like, oh, these are all patterns. These are all patterns. So like the universe, which with supernova, had a match with Elvis Presley and the Beatles and Make. So I started thinking, wow, there's patterns all over the place. So then I found this. This is like really cool. This is like from 2014. So everybody knows what a slime mold is, right? So a slime mold is a one-celled creature. So in the left, here's a picture of France, right, with the major cities, and engineers designed the railroad system in France, right? They spent years and years and years building a very sophisticated railroad system. Somebody took a picture of France and put slime food, which I have no idea what slimy, but put them at strategic spots representing cities, and the amount of food was proportional to the population, and then filmed slime molds. The slime mold duplicated what the humans built because there was a pattern. So this was fascinating. Sort of starts to question like human intelligence, doesn't it? It's like, maybe we're just a collection of patterns too. So this is all very, very fascinating. So it's all about patterns. So there's traditional machine learning that recognizes patterns, right? You feed it data, it looks for patterns, and then makes a prediction. I mean, if you're into weather, this is not unfamiliar to you, right? You build a model and then you project, well, what's the weather going to be like tomorrow? Well, based upon what happened, it's probably going to be nice, and then 3 days from now, you flip a coin because it's 50-50. So that's traditional machine learning. But now we're moving to a different era. So traditional machine learning is recognizing patterns in data and then making a prediction. It won't say it's 100%, it's a prediction. Maybe it's 85%, maybe 60%, maybe it's 99%, but it's a percentage prediction with probability. But now we're in a different era of machine learning. This is like, I wouldn't say, some people call it modern machine learning, but it's just different machine learning. So we're talking about generative AI or ML, language models, and of course, everyone knows the company OpenAI. So a few definitions. So we know what a model is, right? Certainly if you're in finance, you know what a model is, right? It's a persistent entity that recognizes patterns. I have a persistent entity. Typically it's a file, but it could be in a database. It could be, streamed across a network. Something persistent that represents the data. Now, here's something that ChatGBT uses and other models use, large language models. So that's an ML model that's specifically for language. I mean, it's not rocket science definition, it's for language. That's why it's called large language model. And now we have generative AI. So traditional ML is that you look at patterns and you do predictions. Generative AI or generative AI ML is that you generate something new. That's the word generative, right? You generate something new. So it's a category of AI or ML. I mean, AI is the big thing. Machine learning is a subset. It's a subclass of AI, right? And generative AI ML is even a subclass of that. Like everybody heard about expert systems, right? Expert systems is an AI, but it's a different type. It's not ML. It's an AI, but not ML. So it's just different classes of this stuff. So generative AI is when you create something new text. So we're talking about LLMs, large language models, with generative AI. We're generating new text. That's generative AI for LLM. It's nothing new. It's like in my graduate project, since I was a musician, I came across an article in a magazine, I think it was like Scientific American, on creating music in a certain melody, in a certain style, I should say. Create a new melody in a certain style. This was a long time ago. That article was written like in the 70s. Generating something new from a style, from a pattern. So generative AI is not new, but it's new with the resources we have now, right? We have cloud computing, we have GPUs, we have all kinds of new neural network algorithms. Is with the stuff we have now, we now do something really, really cool with it. Sometimes you can predict the future by going back in time and saying, what was a cool idea, but they couldn't pull it off because we didn't have resources. And then you sort of like you can predict the future that way. So here's OpenAI. So OpenAI is a company. It used to be open. They still called it OpenAI. It started off an open source company. I mean, Elon Musk was the first, founders and investors, and he's no longer. Fortunately, everybody on Twitter now. So here's what it is. So OpenAI has a collection of services. Right, it's a collection of services. There's ChatGBT, which everybody in your family knows about ChatGBT. ChatGBT, the cool thing about ChatGBT is the UI. We all know why, good UIs that would make an application. Google.com. It was simple, right? And made it super, super popular. So ChatGBT uses the chat metaphor as a familiar metaphor, right? If you want to bring users in, you give them something that they're familiar with. Make it friendly for people. A chat application, why not? Just use that. So ChatGPT is one service on top of the GDP engine, the GPT engine. Yes.
The internet people know that you're staying too far away from the microphone.
Okay. Sorry, internet people and people of the future, which I moved away from the mic. Sorry. So it's one service. It's not the only service. And in my opinion, ChatGPT is not really the cool thing. It's the thing underneath that's really, really cool. So they have three major services, and I'll talk about more specifics. There's ChatGPT, the web app, and chatbot, right? Then there's DALL-E, right, which is a riff on WALL-E, right? The movie WALL-E, and then Salvador Dali, kind of mishmash of those. So there's DALL-E for images, and there's Whisper for voice to text. Right, so those are the three basic ones. I'll talk more specifically when we get to the API. And then GPT-4 is something called a multimodal language model, which is a mouthful. It's a multimodal language model, which means it's not just text, right? It's images, it's video, it's audio. So if you think about it, where are we moving to? It's not just text. It's a world of video and text and images and all kinds of, we're moving toward the machines becoming an assistant to us. It's not just chatting. It's like an assistant. So imagine like 5 to 10 years from now, when people take these services and they combine them. And we're starting to see things, when you go on Twitter and Mastodon, you see some people that are putting these things together in interesting ways. Now imagine 5 years from now, right? So the machines are becoming more, instead of searching, instead of like, simple things that we think about today, machines becoming more of a real assistant, of a true assistant. Right here, and here's ChatGPT. So ChatGPT, they trained it on text. Right, it's a large language model. It's basically a language ML. So they trained it on books, on Wikipedia, GitHub, the New York Times, web crawls, patents, bunch of things. So a lot of data, and of course we have the nice chat interface. So that's where the data is from. It's from the wide. Whether you like it or not, it's from the wide world. And when we talk about code and when it makes code suggestions, remember, it's coming from the wide world, not from the specialists, not from the people we admire as programmers. It's come from the wide world. But it's the engine that's interesting. It was trained. The engine is really, really cool, but it's trained on the data. So we all know data is really important. And now as we're marching toward this, artificial general intelligence, whether that's in my lifetime or not, I mean, that's like way, way further out. I mean, it's getting better and better. We're probably at the, far end of the knowledge area and getting closer to intelligence, but we don't even know what intelligence is now. And we're finding out that plants communicate. I mean, who knew that, right? So we're still moving towards that. And also, I was thinking about this morning, this is a human perspective. sometimes you think about like, am I being egocentric when I'm saying this? So well, this is human intelligence. It's human intelligence. We're the alphas, right? Who knows, right? Who knows? We used to think that we were alphas back in primitive times. We thought like, no, we were, there's saber-toothed tigers and we were the alpha and we were killing them. It's like, no, actually, no, we were not the alphas. They were preying upon us. This is a recent discovery. So sometimes you have to think like, maybe our way of thinking is so centric in our mind as humans that maybe it's not correct. Very Buddhist, isn't it? So now let's finally get to the meat of the matter, the API. Okay. So there's 7 categories for APIs. 7 categories. I'm walking away from the mic. Okay. So there's chat completion, where basically a chatbot. There's an API. I'll show you the API. It's a simple chatbot, a conversation. There's text completion. Kill this. There's text completion, which says, here's a pattern. I'm going to give you a pattern, and I want you to generate new text, but in that pattern. So that's text completion. There's another service called code completion, which, as we all know, being programmers, that it completes code. We'd say, here's the pattern. Here's what I want you to do. In other words, the pattern. Give me code that matches that pattern. So those are those 3. Image generation is generating images. You specify text and give you images. And then there's Whisper, which is the speech to text, because you imagine if you're dealing with text, we need a voice to text API to make it easy. So they offer that too. So instead of typing in text, you're going to speak, which some people have already implemented. Now, the bottom 2 are really cool. This is where I think we're going to see really interesting things. So the model, the general ChatGBT or the general GBT is trained on basic text of all those sites, New York Times, Wikipedia, GitHub, but you could fine tune it. Let's say you're building a risk management system, or you're building a financial advisory system, or you're building something that's on a certain one of your favorite hobbies, or you're building something specifically for Python programming or Java programming or whatever. You could fine tune that model, give it more data, and then we'll answer more specifically to that use case. So I think that's the area, the fine-tuning area is where we're going to see an explosion of things. Because right now people complain, people that don't understand what ChatGPT is, say, oh, look at the results coming back from ChatGPT. It's terrible. It's not right. It hasn't been trained on the data. So us as programmers, as creators, we can fine-tune the model to our own use cases or our company's use cases. You want to create, actually I was talking to Rodrigo, we were thinking about looking at all of the text from all of our videos, feeding that into using fine tuning, and then either writing blog posts, automatic blog posts from that, or asking questions from the speakers in the video, even though they're not there. And that would be the NYJavaSIG model. So just think about it. There's all kinds of ideas, and I want you to think about ideas. So this is how you use ChatGPT, not just the front end, but how you tweak this. And then there's also embeddings. If you want to get a little more, in depth on how close 2 words are, or 2 sentences are, or anomaly detection, like you're doing spam detection in email or something like that, you can get actual stats, like hardcore floating point numbers on that. So that's very useful. So all these are important, but I think the fine tuning area is the really cool area. Do that. Zoom is swallowing my keystrokes. Okay. All right. So let's talk about some code. So the first thing I did when I was programming, I said, I don't know how to program ChatGPT. So let me ask it, how do you program yourself? So I asked it, give me a curl script. So at least I can understand what's going on before I write the Java program. So give me a curl script that connects to ChatGPT. So I asked it, and it didn't give me back this. It gave me back something similar to this. And I said, wow, that was pretty easy. So I just cut and paste or copy paste, and it didn't work. It just didn't work. Of course, you need the API key, right? So you connect to OpenAI, and 24 hours later, you get an email with your key. But the code didn't work. So what I found out that I said, okay, well, I guess I have to RTFM, and I went into the docs and I said, like, oh, well, this is wrong and this is wrong. So I changed it and I got it to work. ChatGPT information stops at September 2021. It doesn't know anything that happened after 2021, unless you fine tune it. So ask it if Jeff Beck is still alive, and he's not. That's my favorite guitar player. So it doesn't know anything from I think it's either August or September 2021. So in other words, it didn't even know its own API, because I was sending me an old API and it was deprecated, so it didn't work. So that's how I found out, okay, well, its knowledge stops there. So I did read the docs and I got this. So it's quite simple. It uses this, it's a REST interface, or we all know how to deal with REST interfaces, right? So here's the URL. You tell it, like, I want JSON back. Here's my key, right? Whatever, you put your key there. And so the way that you program it, there's a model, right? There's text models, there's images models. It turns out there's, I think there's 72 models that OpenAI offers. And the ChatGPT 3.5 was the one when I created this slide. Of course, there's 4. There's a new one. But here's the interesting thing. There's like this little JSON language here. There's a little JSON. There's -d that I send to curl. What model do you want? And here's messages. Here, I'm a regular user. There's 3 roles. There's user, system messages, and assistant messages. So this is ordinary user. I'm going to ask it, give me the joke of the day. And I got back this. So this is what I got back. And just for the record, JQ is just a JSON utility. You can pretty prints JSON, and you could query parts of JSON. I mean, everybody should have, if you're a command line person like me, have JQ. So it brings you back this, and here's really the output right here. And it says, sorry, as an AI model, I don't have access to jokes, but I can generate one. So it gives me a joke. So that's the output I got from that simple program. Okay, so then I wanted to, I want to not have Zoom take my keystrokes. Come on, man. Okay. So this was my next thing. So I asked ChatGPT to write a Java program. I said, give me a hello world program. And this is tough. This is really tough. Anyone know the alternative for the mouse, for the arrow keys? This is. Yeah. Might need to try their let's try. Yeah, I'll just, yeah, for no mind. It's a nice try. Come on, man. I'm bringing my mouse next time. I am not rebooting. Sorry about this. Okay, so my next thing, this isn't, we're not the Java thing yet, but I wanted to duplicate, the ChatGPT interface. So And the top is just like, that's not important. The important thing is that, yeah, just this loop down here. And the important thing is that I'm getting a message from the user and I just send it to ChatGBT. And then I do a JSON preprint thing. Come on, man. Oh.
On the next slide.
I'm trying to go to the next slide.
What is the first page?
Okay.
What if you switch?
No, it's
Not the presentation mode, but just the slides.
that's my next thing. That's a good suggestion. I'm gonna try that next. Okay. So here it is. I'm not sure what's happening, but so I duplicated the interface by, okay, hello, tell me a joke about it. For some reason it puts this /n first. I'm not sure why it does that, but tell me a joke, what's a good word, talkative, and here's something. Here's invite a speaker to a conference, and it gave me this whole thing about it, how to invite a speaker. Now here's another one. I said I want you to act like a comedian, and then I'm going to give you some topics, and I want a humorous take in a Java programming language. So it gave me, a stand-up bit on Java. But the thing is, here's what's interesting. I gave it a pattern, right? So the pattern is the thing up top. So here's a pattern. I'm telling it, here's my pattern, and I want you to match it with the words that you know. And it doesn't know, so there's no intelligence. It's figuring out what is the most probable word. Actually, the correct thing is most probable token. The token is sort of like 4 words, four characters. So what's the most likely thing next? What's the most likely thing next? Until finally it puts together sentences. So there's no real intelligence. It's just probability of the next words. How about this one? Develop a science fiction script that describes a conversation. And I just made this up. Okay, 2040, there's an Italian boy in vacation in Greece, and he has a quadcopter, he's flying around, and there's a swarm, he's being attacked by aliens. Write the script. So this went on for like 4 pages, and I stopped it. And it wrote me a whole script. And it's actually, it was kind of cool how we evaded the aliens. So, yes.
So are you claiming that the ChatGPT model is essentially local, that it's going from one word to the next, but it's not considered in any way, and this is a story, for instance, the structure of the story, or where it might ultimately try to resolve the story, that it's just A to B to C and make each decision.
It's a little more than that. It's not purely sequential, but it's mostly sequential in terms of its generative things, from what I understand. I mean, in my graduate project, when I was creating new melodies, I just looked at sequences of notes, and then I had a tree of probabilities, and I just went on to the next melodies and generated that way. So it was sequential. The generation was sequential. What happened internally might not have been sequential, but the output was. And since I mentioned the word sequential, what's interesting is that, so what made all this possible? How come all of a sudden the past less than a year has been made possible? Well, in 2017, while the machine learning industry was going a certain way, Google came along with something called the transformer architecture in 2017. Anybody heard about that? What was the big thing about the transformer architecture? Historically, before that, you had to analyze data sequentially. You had to get the data and read it. When I was for my JSR, when I was training it on pictures of like dogs or cats, I would start it and then I would go have a nice long dinner, and like 3 hours later, 4 hours later, just on a few hundred pictures. So the big thing about transformer architecture is that it's parallelizable. So in the cloud, you could bring up all these machines and do training really fast. That was the big thing. And now we're even going further. I mean, Stanford released Alpaca recently. You can do a lot of this on your desktop. So things are flying so fast right now. Okay, so here's the API. I mean, you know how to read the docs. So there's a URL for the docs. there's 72 models. Let me see if I can.
We have two internet questions.
Here, what's the internet question, Gene?
First internet question, ironically, is on topic. Before you pulled up the REST API, someone asked, can I use the ChatGPT REST service when the UI is unavailable due to overload?
Can I use it when the service is not available?
No. When the UI is not available, does the REST API have the same problem? Please repeat the question.
Yeah, sometimes it times out.
Sometimes, well, if you notice that it's quite busy these days. As a matter of fact, when I was writing my demo for today, it just timed out.
So they both.
Yeah.
Can you repeat that instead of saying yes, because you got them right?
So when the UI times out, the service could be busy.
Okay. And the other question, I'm going to repeat the question. Is the OpenAI technology special in that it has such a broad range of knowledge? You say it's all in the UI, but ChatGPT seems so much smarter than other bots.
It's because it's trained on a lot of data and it looks smart. And sometimes if you look at code, it might not be so smart. It's a machine, so you have to question the data you get back from it. It's a tool. It's like Grammarly. Everybody's Grammarly. It's like Grammarly plus. It'll give you good stuff back, but you better check it. Right? It's a good tool. So what I was about to do, and see if I can make this larger. Can you see that? Yeah. Clear CLEAR. All right. So models. So here's a little script that gives how many models there are in OpenAI. So models.sh. So they're all models, right? Oops, sorry. These are all the models. So I think there's 60. Let me see. Models. WC-L. There are 68 models, right? And some of them are for text, some of them are for images, some of them for other things. But so those are all the models. Now, I want to point out to you, because I got bit by this, that language that I showed you back here, for curl-d, you're sending data, it's a JSON thing. Every model has its own way of talking to it. So I wrote Java program. I wrote a nice Java program for a certain model, and it's, oh, this worked great. Then GPT 3.5 came out, and I ran it, and it broke. Every model has its own language, so you have to be aware of that. So you can be, your head will explode trying to get it to fix, just because every model is different. So you have to make sure your code matches the model. So I got bit by that, so don't get bit by it. So here's the API. Things like how many tokens come back, what's the maximum, give me the text that you want, what model do you want to use. There's things like temperature. Temperature is like how creative do you want the answer to be? How creative? If you make it very creative, sometimes it's nonsensical. It's like it's on weed or something. It's completely nonsensical. So it says to keep it like at 0.2. If you put it up to like 2, it'll like, what the heck? It's not even making any sense. So it's very creative. So keep it very, very low. There's a few other options. It's very simple to program it. It's just a JSON object, and you send it that. So here's a Java API. So when my Java API broke, then I said, like, okay, I'm going to deal with a new model. I started, okay, I got to deal with Java with double quotes. I have to deal with JSON with double quotes, and then in my Bash script, I'm dealing with quotes, single and double quotes. There, my head was going to explode. It wasn't dealing with OpenAI; it was dealing with double quotes. It was driving me bananas. So I sort of like, all right, I gave up. I had a margarita. I said, like, I don't want to do this anymore. So then I found a library on GitHub, like we all do. Hey, let me look on GitHub for a library. So there was one called from Little Cat, which was, the code was very clean. He did a really good job. It's not complete. He only covers part of the API. And I mean, both Rodrigo and I were playing around with this. There's another one called OpenAI-Java, which seems more complete. So I'm going to take a look at that. And I would suggest starting with that one first The other one is pretty simple, and the code does a very good job. A good Java programmer, but it doesn't cover the entire API. So this is basically ChatGBT in Java. That's all there is to it, right? He has a ChatGBT object. I get data from the user. I send it to ChatGPT. I get rid of that annoying \n here. And then Rodrigo in 5 minutes created the Spring Boot version. So it was pretty simple. It was pretty simple. Okay. Okay, now here's an interesting part. So I asked it to write a Java program, right? And it gave me back this nice, I didn't format it, but it's a hello world in Java in red, right? So that was fine. Suppose you have this requirement, right? You have a directory of PDFs, and you want a program that reads them, gets text out of the PDFs, and puts the new one in a file, and then name the new ones with an appended sequence number, like 10102. How long do you think that would take you?
To write the code.
To write the code. Working code.
3 hours.
Couple hours, right? Couple hours. So in 5 seconds, you gave me that. And then I said, well, give me another version. It gave me that. So is it totally optimal? Probably I could take a look, but it created it for me, right? It went out and found it. It's not, this is not like a James Gosling quality code. It's just, it went out into GitHub and found the average programmer stuff. Now, think about it, like some years from now, somebody's gonna say like, I'm gonna talk to all the really good programmers and I'm gonna fine tune the model. So it's only good programmer stuff. So I'm gonna sell that model to you. So instead of getting a general view of the general developer solution, you're gonna be able to buy maybe hopefully open source version of the super programmer code. Right? Not now, but you would think that there's going to be, it's like wines, like vintage wines, right? There's certain vintages, right, of certain types. That's what's going to happen. These things would be fine-tuned. So remember, it's not ChatGPT, it's the engine that's the really cool part. So it's how you create the prompt, right? And here's a couple other prompts I was playing around with. How long do you think it would take you to create that, to create a table with cities and that and do the research? You know what? Let's try this. If I can get it out, thank you. So let's just try that. I hope it's not too busy. Okay.
Make that bigger for us old people.
So I also asked it for JSON.
What's also good, you can ask to design a database schema. For instance, I was experimenting, give me, let's say I need to build a pizza company and I need to have customers, pizza types, delivery, and it generates
In a generative schema. Yes.
And he understands how usually those systems are designed internally and how their tables are interconnected.
It generated the JSON, right? So you have to think about this, like, is this intelligence or is this just a tool that I can use? Right? That's right, exactly right. So it's a tool that makes us faster, right? Makes us maybe not better, but makes us faster. We have to make the decision whether it's better or not.
Frank, I use it to work on some Flutter code I was working on. Learn Flutter. A friend of mine said he wanted to design something, so I asked a couple questions about two list views, drag and drop images. It gave me 90% of the code. It compiled, I was like, wow, this is great.
Right. So it knows about all the various languages. This is a really cool. The second one here, it's a virtual. I created a VM in text. I want you to act like a Linux terminal. And then I type this in, and it's as if I'm typing to a Linux terminal, like in a bash, in a command line. You know, things like, what does this sed script do? What does this regular expression do? Right? We're talking about regular expressions before. This is another one. Write a JavaFX application, and I give it the requirements. Like when user types in here, do this, and it gave me back JavaFX application. So this is a super powerful tool, and as programmers, it's here whether we like it or not. But it's a very valuable tool. So it's how you program the engine, so-called prompt engineering. I'm already seeing job offers for prompt engineers. It's how good are you at making the requests to the engine, right? So prompt engineering. And there's probably going to be tools, and some of you are going to be building tools for prompt engineers, right? And we might eventually, of course, there's now different engines, not just OpenAI, but there's, you know, of course, Google Bard's APIs are going to be public soon. There's other ones that are out there. It's an explosion. This is like big explosion. This is like, you know, for me, I'm lucky enough that I lived during Unix and C. That was a big thing. Then it was the internet and the web. That was a big thing. With Java, that was a big thing. This is another big thing. It has legs. There's a lot of things associated with this, not just like a language, a new language. This is a whole new thing that affects us as programmers, but it affects countries. It affects geopolitics. It affects everything. So this is like, it's fascinating. So what's the fastest programming language for this year? Somebody said it earlier. It's English. And to be more accurate, it's human text. It's human. Yes, Ryan.
Just have something when you're talking about having to generate stuff. I typed in some proprietary stuff that we have at work that are proprietary things. That's out there because partners and was able to generate code for that.
For a proprietary language. So it was able to generate code in a proprietary language.
PowerPoints and scoured the internet, it found that we have a language interpreter well, and was able to generate and understand our stuff.
Because it looked at probabilities, right? What was, yeah.
So
That's interesting. That's interesting. I had a similar thing. So a colleague at work, she was writing code. I think she was writing Java code, and she asked ChatGBT to generate code, and it generates really beautiful code, but there was a method there that didn't exist. And she looked at it, she goes, that doesn't exist. And she started laughing. She goes, I first was laughing, but you know what? It actually made perfect sense to have a method like that. So she added the method. So,
Humor, this is not a question, but it's funny from YouTube chat, so I want everyone to hear it. The instructions for Linux emulation sound like you're making a request for a genie. You're specifying every little detail so the genie ChatGPT doesn't do anything you don't want it to do.
you mean the terminal?
Yeah.
Yes, that's true. I'm giving it, well, I'm programming it. That's what you do with a genie. You program it. So this is it's a tool. This is a tool. So our lives are going to change, right? Our lives are going to change going forward. And we need to adopt and adapt to this new world, because if we don't, we're going to lose our jobs. And I don't mean job, I mean another programmer who is using those tools is going to take our job. So you have to learn how to use these tools. So that's my last slide. Any questions?
This is more of a comment, since it's not really programming, but since Microsoft invested so much into OpenAI and they kind of have their own version of GPT-4 internally, they announced like a little less than a week ago their integration of this kind of technology with Office 365. So literally, like have the manager, give me a sales summary report, and then give me a spreadsheet, give me a presentation talking about these points literally through text. In the Microsoft videos on YouTube, you'll find it. It basically shows you what they're presenting. And since it's Microsoft, they can say like, it's going to cost, and therefore we can keep the servers, and therefore it actually will, they will figure out a way to make money off. But
if there's no economics, things won't progress, right? So there has to be some sort of economic benefit from this. You're right, and we're going to see it not just from Microsoft, but other vendors too. You're right. It's going to be in everything we do. As a matter of fact, all the invitations from the past few months for the JavaSIG have been tweaked by ChatGBT. Yes.
Taking a step back and just thinking about it, if tools like ChatGPT are just detecting patterns in code that already exists and then writing stuff in a similar style, is this it? Is this peak programming? Nothing new will come out? It's all just rehashing the old
No,
stuff?
that's an excellent point. That's an excellent point. And I brought this up during my graduate project for music. I said, if we just generate the past, we're just going to repeat the past over and over and over again. That's true. So there is that temperature flag that generates new things that are not quite the pattern. It creates a little more randomness in that. But that is an issue. How the industry addresses that. I mean, I brought this up back in the 80s that we're just repeating the past over and over and over again. All I know is that they gave me my master's, said like that was a good point right there. But you're right. That's a very good point. We cannot just repeat. What happens to creativity? Right. Hopefully that still remains a human thing. That we're creative. We're the ones creative because innovation will be flat then. Right. Normally there's innovation, then a spike happens, right? So humans create that spike. And hopefully in my lifetime, we will remain doing that. 50 years from now, I don't know. Yes.
Maybe yes and no, because creativity is being paid a lot right now. That's why a lot of people invest into it. But if like say these generative models create like this tuning of temperature case thing, which other perceive as like valuable, then the money is going over there. Why buy $100 something which I can get for $1 and then creativity is not funded by it? Thanks.
That's right. It's just the same thing happening with web. When during .com, EarthWeb was a company that charged people to create websites. They charged $1 million to create a website back in .com. Because I know the owner, I know the founder of EarthWeb. He charged $1 million to create. How much is it now? Right. So there's the economics of all this. You're right, and there'll be some better stuff and open source stuff, just like anything else. But creativity, who knows? Maybe we'll find out. Certainly, this is the very valuable tool. Look what happened in biology, protein folding. Like proteins, there's like 200 million proteins, right? They're critical for survival, critical for life. 2 years ago, we only knew about 1% of how proteins fold, because if they misshape, diseases happen, right? 2 years ago, we knew 1% of how proteins behave. With machine learning, we know 100% in 2 years. That's how valuable this tool is. So it might come up with a better way of doing programming, right? A better way. Maybe there's swarms of AI machine learning things, and they collaborate. They might go through the text of data, and they might find like, you know what? If you take that and you take that and you could do this, because as I said, patterns live everywhere. You might say there's something that happens in biology, something happens in programming, something happens in cooking. They actually use the same pattern. Why don't we do this? They might be creative in the future. We don't know. But the thing is that things are going to change. So we have to, because our companies are going to move this way, right? Because they want to move faster. But we have to move smarter too. But so you have to learn how to use these tools.
I find it a wonderful assistant. It certainly uses the past information, but it's creative. If you need to engage, for instance, one day I said, I want to shoot a video explaining Java garbage collection in a captivating way. Let's say that my shooting setting would be my room, my big room, and I want just how to do that. He said like, just go ahead, throw out some stuff and then just pretend that like on one shot, you adjust the application, you throw the garbage and then you collect the garbage. And I said, no, it's boring. Oh, but I do have kids. I have 2 kids. And I said, like, let one of the kids be thread 1, and other kid is thread number 2. And he goes, all right, then they could do this way. Like you show only the kids, put a label, thread 1, thread 2, they're throwing the toys around. And after that, like you appear on the stage and you're collecting all the stuff. I said, sounds good, much better. But how do I decide what toys are garbage and what toys are like live objects? And he goes, no, use some labels, markers. You can put, let's say, something, let's say one toy like green, it means that live, the others are dead. And I go, come on, but when my kids were throwing those toys around, it was not clear what toys would be red, what toys would be green. And then I'm thinking, we'll do it this way. Once the kids threw all the stuff around, then they would go to the corner and they would be playing with some of the toys. Those toys would be the live objects. The rest of the toys would be the garbage. And I would be collecting that garbage, not touching the kids in the corner playing with other toys. And I'm saying, how do you like this idea? He says, wow, that's the best idea. Basically, that's your assistant. Because without ChatGPT, it was a roadblock for me.
Yeah.
And I just wanted to change some thoughts. I wanted to try something out, and this is how you can use it.
Right. That's a good point. It's a tool.
Yeah.
It's a tool. Now, project out 5 years from now when it's not just chat, it's also video, and it's like images, and it's also gestures, and it's also this. So over the next 5 years, we're going to see all kinds of interesting things. The machine's becoming more of an assistant, right?
Hmm.
Yes, Jean.
It's 7:28. Do you have any closing remarks before we do?
The closing remark is that adapt or die trying. So thank you.
My question, but a question mark.